So you would have to inspect the data. You know that everything is all right. So yesterday we had a very brief introduction to how do you actually load a CSV or your data set into Python, and how do you have a look at it, and how do you do some few things to it. So that is what we did yesterday, and yeah, we will take it from there. So I'm just going to brush through what we did yesterday, just brush, and then we continue from there. So here I told you anything. If there is anything I would want you to always remember, it is this thing here, pandas. Pandas in modern day data science, which in future it can change. But as it stands now, anything data in data science, you have to use pandas. So pandas is the main library for any data wrangling, or maybe any data wrangling activity, or any activity related to data. So to load data and all those things. And I told you yesterday that when we talk about library is just like, say it's library in Python is just like a toolbox. So in Python, everything is library based. Python is has a lot of libraries, and it's like it has a lot of it's like a garage with a lot of toolboxes, and each toolbox has a particular set of tools. Maybe this toolbox has tools for fixing a car tire, and then the other one has that of maybe the engine and the rest. So if you want to fix a tire, then you go and pick the toolbox which has all the tools you need to fix a car tire. Then in there you can pick whether it's a spanner or whatever, or a jack or whatever you want. You will see in the toolbox. So the same way in data science or in Python, anything data, you use what we call pandas, the library called pandas, or the toolbox called pandas. Now you have to import it. It is somewhere. If you want to use it, you have to bring it. Just like the scenario I'm giving. If you want to, um, if you want to actually, let's see like this. Let's say your tire just had a puncture, and you want to fix it, or you want to fix it, and you go to your garage, or you want to fix it. If you want to get the tool data, you have to actually go to the you have to go to the garage and pick that particular toolbox. So you go and then you pick the toolbox. If you don't go and pick, then there is no way you're actually going to have it. That is the whole thing. So in Python 2, for you to be able to use any toolbox or library, you have to import it. And we import it simply by saying, using the keyword import, then the library name. So you import and then the library name. So in this case, we are importing pandas. And then the aspd here is just like an alias we given to it. For example, your name is um, Makafu, and maybe I cannot always mention. Let's say everybody has a full name, your surname and your first name. My name is Mutawaki Mikael Newman. So if you want to always call me, you cannot be like Mutawaki Mikael Newman, always Mutawaki. So you can find a short form of my name, like, or maybe a nice way of calling. Maybe either it's an abbreviation or something like that. Something like you can call me Muta instead of Mutawakil Mikael Numa. But it also means the same thing. So in the same way in Python, you import you import what do you call you import the library, and then you give it an alias. Instead of saying pandas, you want to say that I am importing pandas, but I want to call it PD. And I'm saying that you can always change this value, the PD, the alias, to whatever you want. For example, you can change it to maybe whatever you want. Maybe you can change it to Muta, and you say that you want to import pandas as Muta, or you want to import it as Rashad or whatever. But the standard one we use in data science, that all data scientists use, is PD. So that, and the reason why we stick to this is that it will help other people to understand your code, to read your code, and bring some kind of uniformity and generalization to the world of programming. That is why all of us see. You can see if you use Google Colab, you will see some suggestions, down here. Like you can see some suggestions as you can import pandas too. After pandas, you can import other libraries like NumPy and all those things. Now, the next thing I want you to know is that we looked at how we can actually um, do this both on Jupyter Notebook and then Google Colab. Now, if you're on Google Colab like me here, first you have to bring the data set into the into the Google Colab. Why? Because Google Colab is a cloud storage or a cloud solution. It is not your local computer. You're actually working on Google's computer somewhere. That is why you see it says connecting. If you click here, you will see that you have a RAM of 12.7 gig, and then you have a disk that is like storage of 107.7 gigabytes, and you can even have a GPU, which later we will know what a GPU is if you don't know. So it is like a PC somewhere, somebody's PC or Google's PC somewhere that you want to tap into. So you have to bring the data sets into there. And the easiest way to do is to just drag the data set. So you just drag it into this session here, and then you release it, and it will load. And it the first time it will give you this warning, which is fine. Just click OK. And what that means is that if you don't have a backup of your data, since this is not your local PC, for when you close it, you will lose the data, something like that. So once it is done loading, you will see it here, and then you can run the first cell, for example, in the library, and then we load in the data. So with the loading, I told you you call the you call the library name, and then when you call the library name, you do dot read underscore CSV to more like to say that um, you are telling Python go into the pandas toolbox, pick the tool called read underscore CSV, and then use it to read. Or read is simply loading the thing into Python's memory. So read the data set called salaries.csv. And I'm saying that the reason why we use CSV is that the data set is a CSV data set. And how did we know? It is because the data, the name ends with .csv. It has an extension called, it has a .csv extension. Now it tells you that the data is CSV. And I'm very sure all of us know CSV. If you don't know CSV, CSV simply means comma separated value. It is a format for saving data sets or for saving data in computer. And it is simple as simply as um, see it as Excel sheet, rows and columns, something like that. So we are loading in and we are saving it in a variable called data. And if you want to see the data set, you just run the variable in which it is loaded into, and then you have it. Now we went on to look at how you can take a look at the first few rows of it. For example, you want to see the first, let's say, 5 rows, or the first 10 rows, or the first n rows of it, of the data sets. And rows are the horizontal, they are also called observations or record, and then the verticals are columns, variables, or features in data science. So if you want to do that, you just call the dataset name or the variable in which you saved the dataset, and you do dot head. And if you don't provide any number here, the default is 5. So if you don't provide any number, the it will show you the first 5 rows, meaning that the number here will be defaulted by 5. But if you want any number of rows other than the default, which is 5, then you can specify the number, for example 10, and then it is going to show you the first 10 rows of the dataset. As simple as that. Now you can also look at the last observations, in as much as you can look at the first observations, you can also look at the last observations. So if you want to see the first few observations, you use the dot head, and if you want to see the last few observations, you use the dot tail. So the dot tail or the tail, you see you do data dot tail, meaning your tail is down and your head is up. So just like that. And the same way, the default number is 5. If you want anything other than the default number, which is 5 rows, you can provide a number there, and you are good to go. We then looked at, now if you have a data set, you are wondering, if you look at this particular data set, you would see that it has a lot of columns. Now you don't need to count them like literally counting or count the rows. If you want to, sometimes the data sets can be very, very big in real life. So you want to know the number of rows and observations, or the number of rows and columns you have. In other words, the number of observations or records, and then the variables you have. Now, to do that, there is an easier way to do that in Python. And the easiest way is to just call the variable in which the data set was stored, or in other words, use the dot shape attribute. Now you can see that for the shape, you don't end open and close parentheses. You don't end it with open and close parentheses, because it is something we call attribute. An attribute is just like we say, oh, somebody's attribute, attributes of God. God is omnipresent, omnipotent, and all those things. An attribute is just like qualities of it. So in Python, if something is an attribute, you don't end it with open and close parentheses, but we end the ones we end with open and close parentheses are called methods. They are functions. They are special functions. The reason why we don't call them functions but method is that a function can stand on its own. For example, we see you do print and then open and close parentheses and supply, but you cannot do. But a method is a function which cannot stand on its own. It has to be attached to an object, or in other words, it has to be attached to something. So you can see data dot then info. So the info, if you do info, open and close parentheses, and you do data, in Python it will not work. That is the format of R programming, but in Python it will not work. So you have to actually attach it to the object or the data set itself by using the dot. So dot in Python is called chaining. Chain as in bicycle chain. So you are kind of like chaining. It is a way to chain or like stack things onto each other, something like that. Now let's move on to the next thing, which is looking at the structure of the data set. Sometimes you've seen the number of rows and columns, but you actually want to see what are the data types, how many values that each column or variable or feature has. So if you do the .info method, or if you use the .info method, you actually going to have an information of it. And then if you want more details into this, you can actually watch the video on our YouTube channel. Um, we uploaded it yesterday, and you can see that. Um, we also went on to see that, to explore that, or to learn that sometimes you don't want all the columns of it, but you want just as you can specify the number of rows you want to see. You can also specify the number of columns you want to see. But with the columns, you have to give their specific names, the column names, and the column names are the ones which are actually on the found on the this thing, on top of the listing. So for example, this is a column name, experience level, employment type, job type, or job title, salaries and salary currency, and all those things. So to do that, you call the variable name, and then when you call the variable name, you actually, let me do it here, for example. So you call the variable name or the data set. The data set is called data. Now you open and close with square brackets. You can give either you can use either a single quote like this, or a double quote. It doesn't matter. And then you provide the particular variable name. Make sure it is the same as it is on the data set. It is case sensitive, meaning if it is written in small letters, make sure it is in small letters. If it is written in capital letters, make sure it is what it is. So for example, I want to see work here, and I have to do it as exactly as it is. Now if I run, you will see I have only that, and the work here you can see them. Now that you have one particular, you can see one particular column and not the entire one, you would want to see or do, or let me say, whatever you can do to the entire data set, you can also do to one particular column or just a section of the data set. So for example, you can do the .info to see the structure of that particular variable or column of the data set you have actually subsetted. And you can also find the shape by just, so you can find the shape, and the shape you just do this and then dot the data square bracket, the variable name, and then you do dot shape. Might remember that shape doesn't end with open and close parentheses because it is an attribute. Now, you can do any other thing. You can do the dot head to view the first end of few observations. You can do the dot tail to look at the last few observations. Now, you can also watch more than two columns or variables. So if the columns are more than two, you go the same way, but you have to supply the column names in what? In a form of a list. And you know that to create a list, sorry, sorry, you create a list by supplying the items or the elements of the list in a form of what do you call it? In a form of you supply them in between square brackets, something like that. So it goes like this. You call the data set name, and then you open the square bracket. And mind you, this square bracket is for the, there's even the only one variable, we still have a square bracket. So that one is by default. It is a subsetting factor. Now, if you want to see more than one variable, then what we're saying is that supply those variable names or column names in a list. So you have to create another list. And in that list, you can actually provide. Oh, I don't know. I think my mouse is fully today. So in that, sorry about that. Let me fix it right away. So in that square bracket, you can actually provide the column titles, and you separate each from the other using comma, just like you're creating a list. And then you can rerun, or you can run, and boom, you see it. So you can see you have three of them. Now you can also do any other thing you can do to the entire data set to it. For example, do the dot shape to see the shape of it, dot info to see the structure, dot head to see the first end observations, dot tail to see the last observations. Now, you know how to select, how to see the entire data set, how to view the first few rows, the last few rows, the shape structure, how to subset it. Subset, I mean, take only a portion of it. Now, the next thing on the most important thing, or the next important step would be, now if you can subset or pick a particular column, then how best can you analyze this column? How can you, explore the column? And yesterday we started that, and I told you if you have the particular column, the first thing you can do, if it is numeric, like that particular column is numeric. Numeric, I mean the values in that column are numbers. Then you can do dot describe. So if you do dot describe, the dot describe method, what it does is that it actually describes the data set for you statistically. So it gives you the statistical variables or the statistical description of the particular column. So it happens like this, it comes like this. So the first thing to see is the count. So the count is simply the number of observations, or the number of rows that particular column has. And already we know that it is 7,974. And then it tells you the mean, that is the average. And we know this one, we're doing it for the work year. And the work year, if you don't know, let me take this opportunity to explain the data set to you again. The data set we are using is actually a data set about salaries. So salaries of AI jobs or data jobs. So we have a lot of data jobs, and then their salaries and the salary currency and all those things. And you can see we have the work year. So the work year is which year was the data actually taken. So that particular which year. So it can be whichever year. So we don't know where or the span of it. So we can use the dot describe to actually see that. So when we do the dot describe, it tells us the mean um, or the average, what do you call it, year in the data set, and that is 2022.7. But since it is a year is a whole number, so know that you have to round it towards the nearest whole number. That is going to be 22 2023. So the mean or the expected year is 2023. And mean simply means that I know we would have time to do statistics, but let me just come across. When we say mean, it is the expectation. Expectation in the sense that you, when you say expectation, if you pick any job, you expect it to be of the year 2023, and it can vary by 0.53, which is like it can vary by half a year, meaning, in other words, you can round it to the nearest whole number, meaning that if you pick, although we expect the person to be the work type to be, or the work year to be 2023, but that one can differ by what, one. So it is more like 2023 plus or minus one, which is in the range of 2022 and 2024, something like that. Now we have the mean. Mean talks about the minimum observation, or the minimum, the minimum observation or value in that particular column, and that is 2020. Now in this case, we also have maximum, so max for the maximum. So what is the highest value? Now in this case, we have years, so the highest value will be the newest. So 2023 is the newest or the latest year in the data set. And then the first year or the oldest year is 2020. So telling you that, in other words, it's telling you that the data set spans between the years of 2020 and 2023, something like that. Now we have a 20th percentile, and I'm very sure some of us understand what percentiles are, meaning that when you chunk or when you divide the data set into percent, 25% is the same as if you divide the data set into four, the first one, the first part, the first half, or the first quarter. What value is supposed to be there? So it is 2023, and you can see the 50th percentile is the same as median. So you are more like saying, oh, the median, median is simply when you arrange observations, the middle number. So if you arrange all of them, the middle is going to be 2023. And very soon we will know how we can use those ones in data science and make meanings out of them. But it is good, And then now we can also do some plots like histogram, for example. So we can do histogram, and in histogram we can just do that by just doing calling the actual column or variable and just do dot hist. So when you do dot hist, you get the histogram and you are good to go, just like this. And then we can also find the number of unique values in the data set. For example, we have work year. How many different years are in that particular variable? So if you do the dot n unique, it tells you the number of unique values in that particular variable or column, and it tells us four. And it makes sense because the minimum year is 2020 and the maximum year is 2023. So we are assuming between 2020 and 2023, that is 4 years. So we can have 2020, 2021, 2022, and 2023, which is 4 years interval or 4 years span. So the n unique is four, and then we can do the dot unique, that is without n, to see the particular values. So we know that it is four values, but what are these unique four values? We have 2023, 2020, that is from 2020 to 2023, something like that. Now, oh, we have 2020, 2021, 2020, and so on. Now you want to see, okay, amongst all the years, which one, how many 2023s are in the data set, how many 2020s, and that's of the rest. The same way, if you have, for example, if you have what we, let's say, gender, male and female, you have a particular data set, let's say a data about your business, the number of customers who come to your business. So you have collected it over 4 years now. Now you want to see either more male or more female come to your listing. You want to see the categories you have in your data set. How many observations or how many people are male, how many people are female. In this case, it is work year. So how many jobs are or were recorded in 2023? So how many jobs were in 2022, 21, and then that of 2020? To do that, you call the variable name as well, or you call that particular, what do you call it, variable, and then when you call that particular variable, you end it with dot value counts. Mind you, it is plural, value counts. And then that what that does is that it is actually going to count each the values for each category or each unique year in the data in that particular variable, and it will present it to you in a tabular form like we see here. So per the result, you can see that over or more than almost 60% of almost, 80% of the data sets or the jobs were recorded in 2023, followed by 2022, 21, and 2020 is the last. Sorry, guys. So one thing I want you to also know is that you see here it is count. It gives you the count, that is the number of values for each particular year. Now we can also do, let's say we don't want to see the number of values, but the proportions. So proportions rather, if you don't want to see the value counts like, oh, 10 people are male, 10 people are female, then we can actually see, okay, how many percent, maybe 0.4 or 60% or something like that are actually um, males in those things. And to do that, you do the same thing but value counts, but in the square bracket, in the parentheses of the value counts, you add the keyword normalize equal to true. So you are trying to tell it normalize it. So when you add normalize is equal to true, when you run it this time, it does the same thing, but it shows you the percentage. So you can see instead of counting the values for you, it shows you proportions. So telling you that 2023 is actually 75% or 75 0.7563, which is like 75.63, and this one 2023 is 20%, 20.6. This one is almost 2%, and those things. If you cannot see it like this, you can convert them actually into percentages by multiplying it by 100. So if I come here, if I want it in a form of percentages, let me make sure, percentages. Now all I do is I'll just multiply this by 100, and we know how to multiply by 100. Multiplication is simply star. So what you're trying to say is that it should work and then multiply all the values to 100. Now when we do this, you can see now we have 75.63, that is percentage. So 75.63, that is, my guess was right. I said almost 80%, which is true. And then 2022 has 20.69% and all those things. Now we can even, the decimals are very long. We can also round, like we want to round it to two decimal place or one decimal place, so that we can clearly say, because this is like to six decimal places. But for accuracy, you want to actually help. So you want to actually round it to maybe two decimal place. There are many ways to do. The easiest way is to add another dot at the end. So here we want to normalize it, yes. We want to present it in a percentage wise, but we add dot, so dot, and then you say round, and then you provide the number of um, in the round, you end it with open includes parentheses, and in there you specify the decimal place, so maybe to two decimal places. So if it is to two decimal places, you provide two. If it is to three decimal places, you provide three. If it is to four or to whichever decimal place, you provide that number, and then you round, or you run rather. So when you run, let's see, you can see that now it is 0.76, 0. Blah blah blah, and today my this thing is worrying me. Let me rather use this. So when you come here, you can see that we have 0. So if I multiply this by 100, then if I run, and I expect it to be, so 76.0%, but that is not really the case. Why? Because it is actually 76.63. So we want to make it in a form of, or in a way of presenting it instead of 0.75.6333308. We want to have just 75.63. Now, the reason why we are having the answer down here to be 76.0 is that we round it to two decimal places. We round the decimals to two decimal places before we multiply by 100. That is why we are actually having that issue. Now we have to first multiply it by 100, that is converted to percentages, before we actually round it. Now to do that, it is very simple. All we have to do is, let's clean this. and have only the actual this thing. So how you do that is you simply going to sorry, you simply going to let me connect my mouse back. And so you simply going to um, actually round the whole code, this particular code, the entire code, select all of it, and then just click shift and maybe I think it should be 8 on your PC. I mean, wrap everything in open and close parentheses. So you can see we have now wrapped everything in open and close parentheses here. And then in there, right after the normalize equal to true, the value counts this thing. Um, the value counts, what do you call it? The first parenthesis rather, and Python would give them different colors so that you can easily do. So in between, that is at the last point, not outside the outer this thing, not outside the outer parenthesis, but I mean inside it, you have to now multiply it by, I mean, 100. Now, when you multiply it by 100, what you're trying to say is that um, we are converting it just like we did top here. We are just converting it. So when we convert after finishing, if you run it right now, let me just not confuse you. Sorry, you get the same results as here. But if we end it with dot round, and let's say we round it to two decimal places, and then we will see that we have 75.63 like we wanted. And the reason why we had we did it this way is that in Python or in mathematics, we have something we call board mass. I'm very sure McAfee and the math people here, you'd, all of us, I know we remember board mass, bracket of division, multiplication, addition, and subtraction. And what this simply means, is, or what I want you to understand from this board mass whole issue is that when you put something in parentheses, like a whole code in parentheses, Python will execute that one first before it goes outside. So what this is doing, or what Python will do here is, you see, it will execute this particular code here up to here first. So it will find the value count and multiply it by 100. In other words, convert it to percentages before it will round the results. So put it in your head. Mostly when we are working, you will come across a lot of these things. When your code becomes quite complex, you would have to, be like bring these things, and then you are you control the flow of your codes. An example is, let's say I want to, so 2 minus 3, 2 minus 3, then times 4. Now, if I do this and I run, the answer is let's see, negative 10. Now, how negative 10? And this is how it does. Python would, because of board mass, bracket of division, multiplication comes before subtraction, and addition and subtraction. So what Python will do is it will first do the multiplication. That is 3 times 4, which is 12. Then, so here will be 12. What I've selected will be 12. Then 2 minus 12 is negative 10. But maybe you don't want it that way. It's rather you want to do the subtraction first before you multiply the result. That is what you actually need. So to control this, or to override the default thing, you have to put what you want it to do first in the parentheses. So in this way, you are telling Python that, hey, do this subtraction, that is 2 minus 3, before you multiply the answer by whatever is left. So when you put something in code, sorry, in Python programming, if you put something in parentheses, you are telling Python to execute that in the parentheses first before you go to the outside one. Please don't confuse yourself with the parentheses I'm talking about here with the ones like with these ones. I mean, like, for example, the dot value counts. Like, for example, this one to say print and then the parentheses. These parentheses here are actually attached to these ones because they are functions and they are methods and all those things. But if I put or if I wrap all these things in parentheses like this, then I'm telling Python that whatever is in between these parentheses, I'm actually I want it to or I want Python to actually execute that first before any other thing. So that is what I want you to take note of. So um, you realize when we did it here, you were able to understand. I mean, like we were able to get -4 instead of -10, and you can see the control flow or bracketing system of Python. So now we've seen something. Now let's move on to the next thing. Maybe we want to. Um, the next thing I will show you is, let's say you see right now, if you want to explore a different column or a different variable of the data set, we have to scroll to the top and then we go and check the variable names if you forgot it. But there is a way to actually check or list all the variables. I mean all the columns of the names of or all the names of all the columns or all the columns in a data set, something like that. So to list all the names of the columns of your data, so list of columns, sorry, columns in the dataset. How we do is you call the dataset name and you do dot columns and you run, and it is going to actually provide you in a form of list. So we can see we have work year, we have experience level, we have employment type, job title. So this what it does is that it is going to give you a list of all the columns you have in the data set. So once again, um, it is very simple. So if we want to explore different variables, then we can actually um, do that. Now let's explore different variables. Or the next thing is, before I even go there, you see the work here. Now we've seen how to do value counts and all those things. We can see how many 2023s were in, the percentages and all those things. What if I want to plot, or what if I want to plot them in maybe in a way of like to do a little bar graph to show this one is taller and all those things. One concept in data science is that we it is believed or it is proven that pictures actually talk. I mean, they talk or they sound better than they breed understanding than numbers. Most people don't really go well with numbers, but when it is pictures, they go a little well with that. Josephine, your hand is up. So
It's
Josephine,
a mistake. Oh, I'm sorry about
okay, but I
that. It's
hope
a
it is.
mistake.
That's
Yeah.
fine. I hope it's going on well.
Yes, 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 yes. Yeah, it's fine. Yeah.
At any point, if anyone has a question, you can actually prompt me. I mean, by raising your hand up, and I would come back to you. I would hear you out. So now I want us to visualize. Like you are a business person, not always numbers like this. These are good for tabulation in tables form. But what if you want to just do a little bar graph? And mind you, we have a session dedicated to data visualization, creating charts. But I just want to give you, I mean, a clue or more like a first-hand experience to it. So we know how to do the value count. We know how to round it to um, two decimal places, like and all those things or whatever. I mean, to round them to the nearest decimal place of our choice. So let's look at how to visualize it. So I'm going to copy the same this thing. So the same as up here. So you can see one thing I like about Jupyter, I mean Google Colab is that it has autocomplete, and then based on the comments you give, if you start writing, it can help you autocomplete, which is very good It helps you write codes faster. So I encourage all of you to use Google Colab. I'm not saying don't use Jupyter Notebook, but Google Colab, one advantage also is you can log into anybody's laptop. If you log into your Google account, you can always have your codes and those things, the files and notebooks on your OneDrive, and you can always open it and work on it. So maybe you are in a public library, you can always work on public machines and all those things when you log into you. So we can adhere to this. So that is the whole thing I want you to know. So back to the thing. So if you run this code right now, it does the same thing as top here. It just does the value count, converts them into percentage, and then round them to two decimal places. Now I like the tables, but I want to actually plot to do a bar chart. And simply to do a bar chart, you just do you. So you can see we are doing a lot of dots. So at the end, it is in sequential, and all you do is at the end of the code, you bring a dot and you do plot, and then you open and close parentheses, and you say kind. So you do kind, or if you leave it right now and you run, if you just do dot plot and you run, what it is going to do is it is going to plot a line graph for you, which doesn't make sense in this way. So rather, you supply in between the parentheses of the plot, you supply kind is equal to, and then you give a particular. So if you want a bar chart, you just do bar. So mean I want a bar chart. Now if I run this, now boom, you can see we have a very beautiful bar chart, and you can see we have work here. We have 2023. The bar is longer. This way you can easily see. Okay, oh, this one is more than the other, something like that. Now it is as simple as this. And if you want to, you can see there are some little nyama nyama things here. If you want to get rid of that, is you end your code with a semicolon like this, and you run it. The semicolon in programming, any programming language is called a suppressor. And what the suppressor does is it's going to suppress any unwanted output. You can see now it has formatted it very nice, and we don't have that thing there. We only have the chat. As easy as that. Josephine, hand is up. Let me hear your question.
Muta, can we try and work with um a variable like the salaries for the different work year and see how it will come out in terms of the bar chart?
Okay. So, um, I mean, is it? I mean, are you suggesting we choose a different variable and work with, or you're asking like in a form of a question?
So I'm suggesting we do something uh, with a salary.
Yeah, we would do that. I'm actually, building from here to that
Okay.
particular district. Yeah. So I'm just giving an idea of how you're going to go about things. Thank you very much for prompting me, and very soon we'll get there. I can see Josephine's programming spirit has come. Josephine Abi, spirit in Alba. Josephine wants to analyze some stuff and right now apply it to her business. Josephine, it's Cannibal and our kind link. Sure. So back to business. Now you have this, and you can see we have. So this is the x-axis. The horizontal is the x-axis. The vertical is the y-axis. Now sometimes you want to add. You want to add. You would like to add some. I mean, what do you call it? Axis. You want to label the axis so that it will make sense. Right now, you don't know what the y-axis mean, and maybe add some title and all those things, which we can do. Maybe I should show now. Yeah, let me just show. So to label the axis and all those things, we would. I'm not sure with that. Just feel I'm going to use your this thing. I've listened to your advice. I'm going to. or let's just we would actually come back to that. Let's just now we've been able to plot a chart that is a bar graph, and let me copy this and come down because we're going to do something. Now you can see the chart here doesn't have, it only has y x-axis label, it doesn't have y-axis label, it doesn't have a title. Sometimes it may make interpretation difficult for somebody, but how do we actually label the x-axis and all those things? So let's just take a quick look at it. So label the chart. So how are we going to label the chart? So this code here is going to create, so if you run this right now, it is going to create the bar chart for us. Yeah, beautifully, just like we did at the top there. Now, we only have the x-axis. We want to maybe create, we want to label the y-axis and all the x-axis as well. So with that, we have to import another library called matplotlib. So matplotlib is the default or the most popular data visualization library. Whenever you want to create charts and all those things, the first library that comes to mind is matplotlib. We have other ones like Seaborn and Plotly, but this is the most common thing for 2D or charts like this. So to import that the same way as we did for the first one, we do import then the variable name. It is called matplotlib dot pyplot. Then we import it as PLT. So just like we imported pandas as PD, this one we mostly import it as PLT. It's a default. You can import it as P, as Josephine, or as J, or whatever. But the default or the widely or word widely recognized or the convention is as PLT. Now that you've been able to, or let me rather bring this one down so that it will be in a systematic way rather. So we import, and then here the code is, this code is actually um, creating the graph. Let me see. I want to comment them very well so that when you are revising it is very, so creating the graph, and then let's look at the next one is going to be, let's look at how we can um, name the axis, and then the axis I mean the x-axis, y-axis. So to name, we can see that with the x-axis we already have um, the we already have the listing there. It is called work here, but we don't have the y-axis. So to name the y-axis, you use the, so you do PLT because we are going to use the matplotlib library to actually do. So PLT dot y label. So y-axis is called y label, x-axis is called x label. As simple as that. Then you open and close parentheses, and then you can give, so you give the name. For example, if it is percentage, you give percentage. You just type the name, and you can see the autocomplete has even done the job for me. So I'm going to I'm going to do name or label the y-axis percentage, and then the x-axis I'm going to override what is there and actually name it as, what do you call it, um, as a this thing. Um, I want to name it very well, and then to name the title, you just do plt dot title, then you provide a title. So let's call it work here distribution. You can see how easy it is when you're using Google Colab. The suggestions are just awesome. Now when you run it, let's see. Now you can see that the chart has y-axis label. It has a title, very nice. And in this way, it makes understanding very, very, easy to understand something like that. So I'm sure we are able to. So this is the code, and what we did was to, we used the y-axis label to label the y-axis, x-axis label to label the x-axis, and title to give it a title. As simple as that. Now we've known, um, we've explored the work here a lot. Josephine said we should, or Josephine suggested we should go to the salaries. I'm sure maybe she has to do some business with somebody. So, so she wants to know much about the salary. So let's explore the salaries. So with the salary, if you want to get the salary, you just do um, so we just do data, then salary, and then you can see the kind of salaries we have. So we can see the values in here, correct? Now you can do dot describe to find the statistics, just like we did for the other. So if you do dot describe, you would have the values. Now if you can see the count, mean, standard deviation, and all those things. Now you will see it has something like 7.9, then E plus 0.3. This is scientific notation to say like if the values are too big, then Python can make it in that way. So the E is simply 10. Like it is more like to say 7.974 times 10 to the power positive 3. If it is negative 2, mean 10 to the power negative 3. Now, if you don't like this, the easiest way to actually prevent this is to actually round it to maybe, let's say, let's round it to two decimal places. So we end it with dot round, or let me, Josephine, I've listened to your advice. I'm going to go to the next cell and round it and run that code there. So now in the next cell, we are going to take care, or let's say we are going to round it to take care of the scientific notation. And in that way, to make it actually enhances readability because say if it is in scientific notation, even the scientists themselves sometimes get confused. So the same way, let me clean this comment. So the same way, so what we do is we just round it, let's say to two decimal place, and if you run, you can see it is solved. Now you can see it in a very good format. So you can see the mean salary is actually 176,693.58, and that of the standard deviation is 475,717, and so on and so forth. Now, what I would um, what I would say is for the salaries, it is in different currencies. For example, if I work in Ghana, my salary is going to be in Ghana cities. So it doesn't make sense you explore the salaries, but rather you the ones they've converted it to. So let me just if you do data dot head, let's just take a look at the first two observations, and you see we can see that we have actually salary, and then you can see the currency. So it can be in USD, it can be in pounds or whatever, depending on the country you are working in. And then they have the equivalent, that is salary in USD, meaning this salary converted to US dollars. So for example, if I do maybe dot tail, that one would help us to maybe understand this better. So you can see that this was actually not in um, what do you call it? It wasn't in the currency wasn't in US dollars, so it was actually 7 million. 7 million INR. I don't know the country's that country's currency. I don't know where it is, Ireland or what. But I think Indian rupees. Yeah, it's actually Indian rupees. So if you convert that 7 million Indian rupees to dollars, I don't know the conversion rate they use, but as at that time, it would give you $94,665. So that is one thing I want you to know before we even proceed. So after exploring currencies or salaries, I would Rather, instead of exploring salaries for long, maybe let's explore salaries in USD rather, so that we have a uniform, all the salaries are in one currency, and that way we can actually do a better analysis. Because if you are doing analysis and the currencies are not in the same format, it's actually going to be an issue. Later, we will see how we can also convert the money into the or the salaries into maybe Ghana cedis, for example, and then we add it to it, maybe salaries in cedis. So nice. So back to what we were saying. So you can do the dot describe to find the metrics, and you can see the highest salary is actually it's like um, 30 million, which because these currencies are not uniform, we cannot tell. So I would rather suggest we skip the salaries and go to salaries in USD, so that way we know that okay, we have a uniform currency for debate or something like that. So instead, let me copy, but the whole thing still holds. The thing still holds the same thing. So let's explore rather salaries in USD, and the reason is so salary in USD, which is US dollars, USD. Now, so when we give this, um, so all we do is we just do salary in USD. And then when we do the describe, now this way we can do a better analysis. Now let's see. So maybe let's round it to two decimal places, because money is always rounded to two decimal places. Now you can see that the mean or the average or the expected income or salary is 149,369.31 US dollars, and then the minimum salary is actually $15,000, and then the maximum salary is $450,000, which is very interesting to know. So if you were a data analyst or data scientist who was working on it, then you can tell the company that okay, the highest salary so far is 450,000 or 450K um, in our data set, and the minimum is 15,000 or 15K US dollars, with a standard deviation of 64,057.21. Now, let me give you a gist. When you have a numeric value, or when you have a particular variable column whose values are continuous, like it is not whole numbers, it can assume, or let's say they are continuous. Like I know we all know continuous variable. When we say continuous variable, they are like variables like money. They can be maybe 10 cities, 11.2, and all those things. When you want to look at their distribution, the best way to look, or um, the best chart type, or let's say visualization type to use, is histogram. Histogram will give you the distribution of a continuous value. So whenever you have a continuous value, and continuous value, I mean things like age, like numbers, you get it? You always use check the distribution with histogram, and you can also check with box plots, which we will know later. So the distribution of salaries in USD, and then all we do is you can see autocomplete. So data salaries in USD dot hist. Yesterday we saw how we can actually um, plot a histogram. Now when we come down here, we can see the distribution. Very nice. So you can see the distribution. So now let me explain the histogram to you. It tells you how many observations are between like an interval. So the horizontal axis is actually the salaries, and then the vertical is the frequency, or the number of values, or number of salaries, or quantities, or observations, or the frequency in each like bin. A bin is like the bars. So you can see we have 100,000, 200,000, 300,000. So like in between 0 and 100,000 is 50,000. So between 0 and 50,000, you can see we have like around 500 people who earn around this. But you can see chunk of the salaries are between 50,000 and 250,000. So although the minimum is 15,000 and the maximum is 450,000, but you can see the majority of the salaries are actually between this box here, the where the boxes are. So from here to here, that is from 50,000 to 250,000. So it is a way, these are some of the ways we explore the data set, understand it, and use it in our analysis. Very awesome, very interesting. Now you can also add you can actually add or label the charts. Let's add the x-axis title, the y-axis title, and then that of the title. I mean, let's label the x-axis, y-axis, and then they give it a title. Very nice. So we are going to label the charts, and then when we come down here, so for the x-axis, we go plt dot x label. Now what x we want to label it salary, and then in brackets we will put the dollar sign showing oh it's salaries um, in dollar, and then for the y-axis we want to just name it frequency, meaning like the frequency, frequency is just number, and this frequency is actually count. We are counting the number of salaries that will fall into each bin, and then let's give it a very nice title, and then so plt.title, and then let's say we call it so salary distribution in USD. I love this thing honestly, and then let's just run, and we are boom, good to go. Very nice. We have a very nice chart, as simple as that. So we can explore a lot of things. For example, let's it's getting interesting, isn't it? Josephine, is it not getting interesting? Guys, Makafu,
Yes, it's very interesting.
yeah. So let's keep on exploring a lot of the variables, so that we would. I'm sure all of us are enjoying. Rashad, how is it? Rashad is not new to this, honestly. But Jabri, I hope it is getting interesting, right?
Yeah, I've been having a challenge with the presentation. The display is not. It's just stuck at one place. So I don't know whether it's from my end or it's everywhere.
Yeah, I think it should be your network.
Yeah, I've been disconnecting myself and connecting back, but it seems to be
Sorry
glitching.
about that. Sorry, I'll upload
Yeah,
the video right after this.
all right, no problem.
Sure. Yeah, Josephine, your hand is up. You can speak. Okay. Josephine, I hope you can see my screen. It moves. It is not static as Jabber
Yeah, it
has
moves. It's
experienced.
not static.
Oh, okay,
It's
that's
not. It's
awesome.
not static.
That's very awesome. So, guys, we cannot keep waiting. Let's pick the momentum and go and explore all the variables. You know, let's go and explore them. Quick, 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 quick. So, the next variable, let's pick. We have experience level. We have um, employment type, we have job title, we have salaries, we have salaries in USD, we have salary currency, and all those things, and remote ratio and stuff. Now, I let's explore which one do you think we should explore next? Let's think of okay, but before that, let me give this thing. We have two types of I don't know whether you've realized we have two types of data sets or data type in this particular in the columns. We have numbers and we have non-numbers. or non-numeric. We have numbers and non. So those which are not numeric, you can see we have like senior level or this. We call them categorical variables. They are categories, just like gender. Categorical variables are they are like groups. They have categories. You can actually belong to one. For example, be a male or female. You can either your job can be either senior level, beginner level, or something like that. So the ones which are not values, like the experience level, the employment type, the job title, those ones are called categorical variables, and those which are values are called numerical variables. Yeah. So we have ways to. So let's explore. I think let's explore experience level. Yeah, let's explore the experience level. So I would do some and tomorrow I'll upload a quiz. I mean, work. So it's just going to be you extending what we've learned to the rest of the variables we didn't do. And then when we meet, you show your work or something like that. In a way, so that you don't forget what you've learned and you would learn more even to that. So let's explore experience level. Experience level. Now with the experience level, since it is so the first thing is obviously find the describe, and let's see, it will tell us. So when you do the dot describe, since it is not numbers, you cannot find the mean and then the median, the average, and those things of non-numerics. So you cannot, so it gives you different ways. You will see the count, that is the number of observations or number of rows in that particular in the experience level variable, and you see unique, how many unique values are in it. So you can see we have four unique values, meaning we have four different experience levels in that particular column, which is very interesting to know. And then the top, that is the the highest or the most frequent or the I mean the one that um, experience level which occurs most, or in other words, the mode is actually SE, which stands for senior level. So, and then the frequency is 5,754. That is the number of this thing, the number of times it is in the data set. So, the next thing is we can actually do a value count. We are curious. We can actually do a value count or check the unique experience levels, the actual unique experience levels we have. So we've seen that we have four of them, but we want to see how many of them. And to do that, you do data experience level. We use the unique, not n unique. N unique is to find the number of unique values you have. But already we've seen it here. So we just want to go straight and see the unique values we actually have, them like the unique values themselves. So when you come here, wow, we have SE, MI, EN, and EX. Now SE is senior level, MI is like middle level, and then EN is entry level, that is beginner role, and EX is executive level. So it is true we have four unique values in there. And it is good you explore your data set this way, then you can actually understand it and then do what is needful and communicate, you know, a lot of sense to stakeholders. Right. So now that we've seen we have this SE, which is senior level, MI, which is um, mid-level, EN experience, and sorry, entry level, EX is executive. We can actually, well, let me add it here so that you don't forget. Yeah. Let me add it here. So SE actually stands for senior level, and then MI stands for mid-level or middle level, and then we have EN for entry level, and then we have EX is executive level. executive level. Now let me just make them bullets so that they can be formatted in a nice way. So so nice. Now let's see how many senior level roles are in the data set. How many mid level? I mean, we are curious. We want to know. So to check um, how many or the distribution, how the distribution of experience level. That is how many of whatever we have. Then we can actually do dot value counts, which is very simple. So dot value counts, we use the dot value counts so it will count the values for us. So we can see that here SE, that is senior level rows, are 5,754, followed by mid level ones, which are 1,554, 1,546 rather. Entry levels are 429, and executive levels are the coolest. Now, you see from the above there, when we did the value count and we wanted to maybe, um, we wanted to visualize it, we have to copy the code again and then we come in. That is what variables do. So because we have learned variables and we know that with variables we can save whatever information we want in a warehouse somewhere and later we can always access it. I would rather like to save this in a variable so that I can just call the variable instead of writing the entire line of code again and just adding the distance. So I would like to call this ESP, that is experience level. It's or let's say ESP level, ESP underscore level. Out so meaning experience level, like short form. So if you do ESP level, fine, we get whatever we want to. Now, if you want to visualize it, let's say you want to do so visualize. You want to do some bar chart for it. Visualize it. Then instead of copying the data, blah blah blah, we just do experience level dot plot. So we just call, let me complete this time. So we do dot plot, and as usual, kind we want a bar chart. So we say kind is equal to bar. Now when we run, we get a very nice bar chart. Now this way, I don't want the vertical bar chart like this. I want a horizontal bar chart. If you want a horizontal bar chart, instead of saying bar, you just do bar H. Bar H means horizontal bar chart. And then you get, you see, it is different from, this is more like the horizontal way of things. And then maybe we don't like it this way. I want the taller bar, I want it to be arranged in descending order, like the tallest on top, followed by in that order. This is in ascending order from smaller to bigger. I want it in the other way. So to do that, you just do dot sort values, and then in there, let me delete this first. So you do dot sort values like this. You end with dot sort values, and what this is going to do is it is actually going to sort the values, and we have an error here, and then it is because we have to specify ascending. So we provide in there that ascending, sorry, is equal to true, meaning that we want it to actually, and still we get an error. So we get an error. It is telling us that axis object has no attribute sort values. Okay, so maybe instead we have to, so before we plot it, we actually have to sort it before we plot. So let's So we have experience level. We have to actually sort the values before. So once we sort the values, now we have it in descending order, or we can say ascending equal to true, and in that way we are saying okay, ascend it in this thing, or we can set it to false so that it will be in descending order. Now you will see that here the bigger one first in those days. So after sorting it, we can actually plot it with a horizontal bar chart, that is bar H instead of just bar, and then we are good to go. Now, if we set this to true, it will come to the ascending, the way we want. So something like this. Very, very awesome. As simple as that. Now, one thing I want you to know is that you see in the kind here, for example, if you wanted a bar chart, you should, in the where we did the bar, you could have just if you change it to any chart name. For example, if you change it to chart, pi, it will give you. Let's see what it gives us. It will give you a pie chart. So if you change it to pi, it will give you a pie chart, and you can see we have SE, which is the red one, MI, which is the listing, and those things. If you change it also to the bar H, the bar H, then we can have what do you call it? The horizontal bar chart. If you change it to bar, you have the vertical bar chart and a whole lot of other stuff. So maybe you can explore. Some of them doesn't work, some of them do not work. For example, what I'm trying to do, you don't have box plots, or if you want to do a box plot, we have a way of doing it. Or you give it box and then it will give you a box plot. So just changing the things there, or what is in here, the kind. If you change it to box, you get a box plot, very nice. And if you change it to bar, you get a bar chart and all those things. So here we want bar each, that is horizontal bar chart, and we have it. So now the next thing is we would like to actually label the chart. That is, give it a title and those things. So let's give it a title. So you can see it has just um, suggested and it is true. So I want the plt.x-axis to rather be now. If you do horizontal bar charts, see something, because it is horizontal, you can see that the bars are rather on the horizontal axis. So here the y-axis rather is the values, and then the x-axis becomes the frequency, unlike the vertical bar chart. So here we will say that we will call the y-axis experience level, and then we will do this one count, that is, or frequency, and then the title is going to be experience level distribution. Now when we run it, you shouldn't get any error, and we are good to go. We can just copy this and do it for the pie charts, and then also, so I'm going to copy this guy, and then we do it for the pie charts and all those things. So let's create pie charts. So all you do is the same code, but you just change type equal to pi, or the kind equal to pi. Now when you run, you get this. Now for pie chart, we don't have x-axis and y-axis, so we don't do x-axis and y-axis, and but rather you can actually label a chart, which is as suggested here. So experience level distribution, you can give it a title just like that, and then you are actually good to go. We would look at how we explore other stuff. Now let's look at how we create the box plot. I just want to show you so that when you are there you can have a lot too. So with box plots, you just do. We have many ways you can do. If you bring it down here, you can see we can just paste this and then change this to box, and then when we run, we should be fine. Now we have it, and then we can label it, for example, and Google Colab is doing it, doing all the job for us. Autocomplete. It kind of understands it and then gives you what you are supposed to. Now your work is to. We will get there. We would understand the the box plot and all those things. But it is good, you can create box plot and all those things. You can create pie charts and all those stuff. Now, what I would entreat you to do is pick the other ones, like the other variables. For example, we just explored few of them, and we cannot do all of them. And even if I do all of them, that is no good because you will not have something to practice with. So things like job type or employment type, you can explore it to see how many employment types do you have, and then what are they, and then which one is the which one has the highest, which one has the lowest, and all those things. You can try to plot them using pie charts and all those things we've learned. And when you encounter any issue or any problem, you just slide into the group and you put your problem there. You can even take pictures of it and put it in there. We would help you out. And or you can reach out to Mama, or you can reach out to me if it is really, really serious. Yeah. So um, I've been talking for a very long time now. I want to just see, and I want to pause here and use the rest of the. We have few minutes, like less than. We have like literally by my time 11 minutes. So I want to take your questions, and we proceed. So if you have a question, you just raise your hand up, and I'll call you and be good to go. So okay, Josephine, I like that. Josephine, go ahead.
Later, when you get these results and you have to interpret it, is there any fixed way that it has to be interpreted, or whoever is working on the data set would have maybe their own way of interpreting the data set or the result?
Okay, so interpretation, actually one key thing is you look at which people are you even communicating, or I mean let me say reporting to. So the people or your audience will first um, give it or help you know your words you use and how you're going to go. If they are, for example, if you are reporting to me, I'm already a technical person. I understand your this, don't waste your time like that. But if you are reporting to managers and all those things, all those non-technical people, you would choose your words in such a way that you're not going to use technical data science words, and you're going to do by your the business standards, like come to their level. And also, it depends on the field. If it is marketing, you have your marketing terms, so you would use your marketing terms. If it is, for example, sales, if it is maybe like where I was working, we were more of research. You know how you do. If it is also finance, you know how you choose your way. So there is no fixed way of actually interpreting, but you make sure you don't lie, and you make sure that you 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 choose your words, or you choose your way of reporting or way of communicating results, or communicating insights and results based on your audience and then the nature of your work. So that is how it is. And we would come there very soon. We would learn, we have a section on how to communicate insights. There are ways, like general ways you can actually communicate, how you can convert these metrics, make meanings of them, and then bring them to normal business standards and make. minutes of it, something like that. Yeah. So, Josephine, I don't know whether I'm making sense. Or...
Yes, my question has answered. I would like you to go back to the analysis on salary in USD. You know, I don't know if this data is the real data. If it is, then of course any data science kind of thing is lucrative because please go back there and let's see. I'm looking at the average you had.
Okay.
Yes, I want you to interpret that average on the fact that the number of years we are observing in this current data set is 4 years. So
Yeah.
what does this average figure we had mean for us upcoming data scientists if we have to rely on such data to make a decision whether we really want to pursue data science or we want to get out of it?
Okay. So I think it's really awesome. So that is here. So before I even proceed, the truth is, in this field, there is a lot of money. But before you make money, as in any other field, you have to do the work. You have to get the right skills and all those things. So especially out there, there is a lot of money. I remember when I was working for the company in Fargo, I was paid very, very well. I was paid more than my lecturer and those things. So that is one thing I want to actually assure you. And the next thing is, now let's come back to the figures we have here. When we say mean or average, another name for it or another statistical name for it is expectation. We have a data set within an interval of 2020 to 2023, that is, um, let's say, almost up to current, that is 4 years span. So you can interpret the mean as this. So it is expected that, or the expected salary, let me put it this way, the expected salary for any data science job or data related job is 149,369.31. Sometimes you go to websites like Indeed.com, Glasgow, LinkedIn. This is how they do the analysis. They take data sets, and this data set is actually a real data set. It's not fake. It's actually a real data set I got from somewhere. So it is not fake at all. And so, but we don't have everybody's system. The per data, which is a sample of the world's data we have, it is expected that, or the expected salary of any data science professional is almost 150,000 US dollars. However, your salary can differ from this. That is a standard deviation. Your salary can differ from this by 64,000 US dollars. Why? Because we have, you know, experience level. For example, if you are a beginner, you don't expect to have your salary as the same as a mid-level or a senior or executive role. So although you are expected to receive 150,000 US dollars, but your salary can differ from that mean, from that expectation by the standard deviation, that is 64,000 US dollars. So, in other words, if you are doing your calculation, you expect your salary to be between the mean plus or minus the standard deviation. That is 149,600 and this thing. Let me maybe bring the code here. So, you are expecting your salary to be around the mean minus the standard deviation and the mean plus the standard deviation. That is, you are expecting your salary to be around 150,000 plus or minus 64,000. So it can go up or it can be between this range. You can receive any salary between this range. In other words, if you receive any salary below that, then you should know you are being cheated. That is how it means. And then the minimum salary is 15,000 US dollars. And mind you, these values are actually yearly data, yearly salaries annually. So you divide it by 12, it will tell you the number of the amount you take every year. So for example, if you have 100 and this thing, if you divide by 12, then it means you are making around $12,447 in a month. Yeah. So, like I was saying, if you want to do your analysis, it is this plus. So, standard deviation tells you the spread, how your observations can sorry can deviate from the expectation. Although you expect sorry you expect your salary to be 149,000, let's say 150,000, but it can differ by the standard deviation or it can vary. So if you are doing your analysis, you do it like this. So this is a plus, and let's do for the minus. So if you do for the minus, so oh sorry I didn't do. So now you add the standard deviation and subtract. That will give you your range. So here you can say that the expected salary of any data science or data professional, being it machine learning engineer, whatever, is actually 150,000. However, it can differ by 64,000 US dollars, meaning that if I am taking a new role, I expect my salary to be between 85,000 and 213,000. So my salary should be between this range. So that is how we do the analysis. So standard deviation measures the spread, and always when you have mean standard deviation, if you are going to do your analysis, when you add the standard deviation to the mean and you subtract, it gives you the lower and upper boundary. And you can say that so you expect the value to fall between that particular range. Josephine, I don't know whether I make sense and I've been able to maybe explain to you.
Yes, yes, yes. It makes so much sense. Thank you so much.
You're welcome. So that's how we do our analysis. Um, Now, Josephine is, or all of us are almost, we are entry level data scientists, and I like how we are all doing. Josephine, are you shocked? Are you moved by the money?
Oh yeah, I'm looking at the money and yeah, it looks good.
Yeah. So you can also look at the job. Yeah, it is actually true. Um, Even data science boot camps, they really cost. But for me, I my goal is as a human is not just to make money out of people, but also to empower. So that is how come we start from there. Maybe in 2 years to come, our value will grow very, very big, and you have to pay more to come and learn from us. So that reminds me, let's look at the different type of jobs we have. So you can see that in job title. So the job title will tell you the particular job titles you have. So you can do data and then you do job title. And we can actually look at it. So we can look at maybe value count, or if you want the actual jobs, we just do dot unique, and it will give us the unique values. We have a lot of job roles, so this is also a learning curve for us. If you are learning data science, it doesn't necessarily mean you will be only data science. You can be a business intelligence engineer, you can be data manager, you can be data scientist, machine learning engineer, analytics engineer, data architect, machine learning engineer, data engineer, data analyst, research scientist, computer vision. So what this tells us, or what insight we get from this, is that sometimes if you are even applying for jobs, every company has title for whatever role they are saying. So it is not every company which will call a data science role data scientist. Some of them call them business intelligence engineer or business analyst. For example, if you are working in a bank, they will not call you data scientist. They will call you maybe a financial scientist or financial research scientist, or maybe financial analyst, something like that. If it is a tech this thing, most of the times, for example, in my company, First AI, they would like to call you a data lead. So instead of saying a data scientist, where I was working, I was called AI research scientist. You can see here research scientist. Some people call it um, product um, product scientist or product data science scientist, or maybe product analyst, product manager, and all those things. So um, there's a lot of names for this, and there's a lot of actually a lot of professions. I mean, sub professions or a lot of career options in data science. So after learning this, some of these roles you have to actually specialize to get them. Some of them too, they are just like they are just different names given to the same thing. I hope we are making some insights from this. So the reason why I chose this particular data set is something like this. Not just the thing I'm teaching you, but you are also learning the actual or the reality of data science. I hope everything is well. Any questions? Makafui, do you have a question? Rashad, Josephine, Fridolin, Jabri. So Josephine, you can ask a question.
Okay, so Muta,
Yeah,
please, so yesterday you mentioned that um
your line is breaking. I don't know. I
can you
can,
hear me?
yeah, I can hear from
You
you.
mentioned that if we want to explore like careers in data science, we have to be doing projects. So maybe from time to time you can be coming up with the kinds of things you think we can be doing in terms of projects that could enhance our chances of, leveraging on the little knowledge we've gathered so far.
Yeah, that
Maybe
is
at
true.
the career sections or something like that.
Yeah, that is very true. So even because we just started, very soon. So you see, this thing we're doing is actually like how we do projects. So we are going to, you see, these data sets we are exploring. We will explore. We are going to use the same data set to from where we are now to all the other stuff we're going to use, and then we will pick another data set and explore. So very soon, when you have the foundations, the rest of the lessons are going to be project based. For example, we are building a model to predict cancer. So we pick the data sets. Now you know how to load it. You know how to do some data cleaning and all those things. You know how to explore, and you know how to build the models. So that is how we're going to do. And we use the career sessions to build unique things outside the class, just like you say. So all of us are entreated. So whilst I'm talking, I am the facilitator. You are also listening. Ideas come to your head sometimes, and sometimes they come to me. So when we come on a very good idea, we can write it down, and when we have career sessions, just like Josephine is saying, then we build a project on that particular idea. And if you have the idea you want me to help you make it personalized, that is fine. I can also guide you as well. I don't know whether it makes sense, Ali. Josephine, is that cool?
Yes, yes, that's cool.
Yeah, so by the end of this project, or by the end of this boot camp, everybody will have three projects done. Conk. So very soon we will build one project, another one, and then a capstone project. But we would help you with other stuff too, so that you can, by the end of all these, you can explore ideas and do a lot of projects on your own. So that is what it is. So is there any other question? And sorry, today we've overstayed. I hope you guys will forgive me. We've exceeded our time. We're supposed to close at 10. It is 10:06 now. So any questions, guys? Well, so if you don't have any question, I would like to end here, and thank you very much for coming. Anytime you have any question, please don't wait for another listing. Just come to my DM or put it. I would prefer you put it on the listing on the platform so that all of us will see the question. Maybe if Josephine has an answer, if Abdallah, Jabir has an answer, Rashad or any of us have an answer, we can actually help. And also we can also learn from your questions. So you put it there, and Anamwa is always there to help you. And I'm also there when mostly in the evenings, for me daytime days, my things are a lot of things. I have to. work on the things I'll teach you and all those things. But I still do my best to, especially when you DM me, we talk. Yeah. Thank you very much for coming. If there is anything, you can come to my DM. We talk about that, or you go to the listing. I will see you on Wednesday for career session, and we will discuss amazing things. We've started this. We will discuss a lot of project ideas, Josephine, like we did. So thank you very much, and then mind you tomorrow or Tuesday, I'm going to upload your assignment. So I'll see you soon. Have a good night. Thanks for coming.